Happy Wednesday! Still miss being in the classroom with you. Hoping you're liking this new method, a shorter video and then a Flipgrid with lots of examples for you to practice as much as you need to. So get your notes ready. Here we go. Today's goal is to write a repeating decimal as a fraction. So that's the goal for today and tomorrow, is that you can write a repeating decimal as a fraction. So if we were to ask you to write 0.2 as a fraction, you would say 2/10 because the 2 is in the tenths place, and then you would reduce it to 1/5. On a calculator, if you did 1 divided by 5, you would get 0.2 as your answer. But if we want you to write 0.2 repeated as a fraction, and you said 2/10, that wouldn't work because you wouldn't get 0.2 repeated, you just get 0.2. So today we're going to go over what you do if you have a repeating decimal and you want to make it a fraction. Repeating decimals are rational numbers. We'll talk more about types of numbers next week. But it's a rational number because you can write it as a fraction. So because it is rational, they can be written as fractions. So we're going to skip the directions. They're there for you to go back to if you need to. And we're going to go to some of the examples. So it is a super easy trick. If we want to write 0.7 repeated as a fraction, instead of putting it over a 10 or 100 or 1,000, we're going to use nines. We're going to use a 9 for every number that repeats. This decimal has one number that repeats, so we're going to put 1 9 in the denominator. This number is our numerator. Then we're going to check to see if we can reduce it. We can't. So if you did 7 divided by 9 on a calculator, you would get 0.77777 repeated. Here we have two numbers that are repeating, 0.070707. So for this one, we're going to use 2 9s in the denominator, one for each of the repeating numbers. And then on the top, we're just going to write that number. Now we don't need to include the 0, and we can't reduce this, so our answer is 7/99. If you did 7 divided by 99 on a calculator, you would get 0.070707 forever. The last one in this row, 0.18 repeated, there's two numbers that repeat, so we have 2 9s in our denominator. 18 is our numerator. Now we're going to look to see if we can reduce it, and we can. Both of these numbers can be divided by 9. So we're going to get 2/11 as our final answer. In the next row, there's something different going on. We have this 0 that doesn't repeat. So when you have numbers that don't repeat, you're going to put a 0, you're going to add that 0 in as a placeholder after the 9. We have 1 9 because the 1 7 repeats. And then we have a 0 that we're going to add on as a placeholder. Then our numerator is just 7. This can't be reduced, so this is our final answer. If you did 7 divided by 90 on a calculator, you would get 0.077777. So zeros that don't repeat get added onto the denominator. Our next example, we have two numbers that are repeating and a 0 that isn't. So we have 2 9s for the numbers that are repeating and a 0 for the 0 that's not repeating. And our numerator is going to be 13. We can't simplify this anymore, so our final answer is 13/990. The final example in this one, we have two numbers that repeat, so we're going to have 2 9s for sure in our denominator. Then we have 2 zeros that don't repeat, so we're going to add 2 zeros to the denominator, and our numerator is 13. For the final row, these ones are a little trickier. We're going to use the same setup for our denominator. Finding the denominator is fairly easy. We have one number that repeats, We have a number that doesn't, so I'm going to put a 0 next to the 9. Now, because this isn't a 0, to get our numerator, we're going to take this whole decimal number, which is 18, and from it we're going to subtract the number that doesn't repeat, which is a 1. So our numerator is going to be 17 over 90. If you did 17 divided by 90 on a calculator, you would get 0.1888888 forever. So for this next one, we have a non-zero number that doesn't repeat. We're going to get our denominator the same way we have been for all the other examples. We have one repeater and one non-repeater. Our numerator is going to be 53, which is the whole number, minus the part that doesn't repeat. 53 minus 5 is 48 over 90. Now we want to look to see if we can reduce that, and we definitely can because both numbers are even, so we can start by dividing both numbers by 4, or if you know your multiplication facts, you'll know that 6 definitely goes into both numbers. 48 divided by 6 gives me 8. 90 divided by 6 gives me 15. And the final example over here, it says, so what does 0.9 repeated equal? So if we use the same trick that we use this whole sheet, we have one number that repeats, so we get 1 9 on the bottom. Our numerator is also a 9, so we get 1. 0.9 repeated is the same exact number as 1. There is nothing different between 0.9 repeated and 1. And if you're not sure that that is true, if you think about what you know, if you think about 1/3, most of you know that as a decimal is 0.3 repeated. And if we take another 1/3, that's another 0.3 repeated. And if we take another 1/3, that's another 0.3 repeated. These all equal each other. So if we add them together, we should get the same answer. 1/3, 1/3, and 1/3 is 1. 0.3 repeated and 0.3 repeated and 0.3 repeated would be 0.9 repeated. 1 is the exact same number as 0.9 repeated. Now we're going to go over just a list of good repeaters that you should get used to seeing, so it's easier if you have some of these memorized. 1/3, most people know, is 0.3 repeated. 2/3 would be twice as much, so that would be 0.6 repeated. There's a nice trick with 1/6. 1/6 is 0.16 and just the 6 repeats. 5/6 is 0.83 and just the 3 repeats. I'm going to skip this one for a second. The 9s, any fraction that has a denominator of 9 is just that number, that's the numerator, repeated. So 1/9 would be 0.1 repeated, 2/9 would be 0.2 repeated, 3/9 would be 0.3 repeated. The 11s is a nice trick for the 11s as well. 1/11, if you take your numerator and multiply it by 9, and make it a 2-digit number, it's that number repeated. So 1/11 is 0.09 repeated. 2/11 would be 2 times 9, which would be 0.18 repeated. 3/11 would be 3 times 9, or 0.27 repeated. Now for these two, there are a longer string of numbers that repeat. 1/7 is 14, 28, 57, and that all continuously repeats. So 14, your age, double it, and then put my age at the end. 14, 28, 57 repeated. And then 1/12 is half of a sixth. So it's going to be 0.083 and just the 3 repeats. the more of these that you recognize, you'll see them all the time. It'll make some math that you do much easier. Definitely, you should know these ones. They're very easy tricks to know, and you'll see them often.